All right, so this is 2.4. It is the second part of 2.4. In the last video, we went over solving systems of two equations from applied word problems. And what we're going to look at in this section is not word problems, but solving systems of three equations. Okay? And the way that we want to try to solve systems of three equations is we want to use pairings of those three equations to eliminate one of the variables. Because if we can get rid of one of the variables and just have two equations, then we can solve it the same way we did in the last video. Okay, so I'm going to show you the quickest and easiest way that I can think of to solve those types of problems. So what I'm going to do is I'm just going to number these equations, number 1, number 2, and number 3. And that way, whenever we do different things to different equations, we have kind of a reference for which ones we're doing. So when I look at this, when I say clear a variable, I'm hoping to eliminate a variable. Now the only way to eliminate a variable is by adding two equations together. And when I add two equations together, if the variables happen to be opposites, then they cancel, right? They combine to 0. So I'm looking at this one and I'm going to go ahead and just clear x. Okay, you could clear y's or z's, it doesn't matter, but just for the sake of picking one, I'm going to pick x because I see on equation 3, I have just a regular x. There's no coefficient other than a 1, so that one's really easy to change into something that will be the opposite of another equation. So let me show you what I'm talking about. So I am going to use equation 1 and equation 3, okay? And my goal is to clear x. So I'm going to write here, clear x. And I'm actually going to zoom in just a little bit so we can see this a little bit easier. Okay, so I'm hoping to clear x. Now look at equation 1. The x is 5x, okay? And on equation 3, it's just a regular x. So if I want those to combine, I need those to be opposites, right, in order to eliminate them. So I would really like the x on equation 3 to be a -5, so that when I combine those together, they'll combine to 0. So what I'm going to do is I'm going to do -5 times equation 3. And I'm just going to write that right next to here, okay? So if I do -5 times x, that gives me -5x. If I do -5 times -3y, just distributing that -5 to every term in equation 3, I end up with +15y. -5 times 2z gives me -10z. And -5 times -25 gives me +125. Okay? And then I'm hoping to combine this with equation 1. Now equation 1, I'm not going to do anything to it. So I'm going to leave it 5x minus y plus z is equal to -15. And remember, our goal was to combine these two equations so that our x's will cancel out, which is going to happen now because our x's are -5 and +5. So when I combine down, that becomes 0, right? And then I combine down on all the other terms as well. So 15 minus y leaves me with 14y. -10z plus z leaves me with -9z. And 125 minus 15 leaves me with 110. Okay, so what I have created is now a fourth equation, okay, that only has y's and z's. So that's going to be a lot easier to solve because now I only have two unknowns. But if I have two unknowns, I need two equations to be able to solve it. So I've created one. What I need to do is create another equation that just has y's and just has z's so that I can use these two new ones to solve. So before I started with equation 1 and equation 3, so I'm going to pick a different pairing. I still would like to use equation number 3 because equation number 3 is a really easy x to just multiply it by something and make it the opposite. So I'm going to use equation number 2 and equation, let me find my, there it is. So I'm going to use equation number 2 and equation number 3. Okay, again to clear x. Notice on both of these I am clearing x. I'm clearing the same variable. It doesn't do me any good to clear a different variable because I want to be left with the same leftovers. Notice my equation number 4 has the leftovers of y and z. So I need to clear x again so that I get another equation that has the leftovers y and z. All right, so if I use equation number 2 and equation number 3, and I look at my x's, one of them is a 2x and the other one is an x. So equation number 3, I really need that x coefficient to be a -2. So I need to multiply equation number 3 by -2. So I'm going to do -2 times equation number 3, and I'm going to write that here. So if I multiply every term in equation number 3 by -2, I'm going to get -2x. I'm going to get positive 6y. I'm going to get -4z. And -2 times -25 is positive 50. Okay. And then equation number 2, I'm going to leave exactly the same as it is. So it's 2x plus 2y minus 3z is equal to 24. Right? And then I can go ahead and draw my line and combine straight down. So when I combine straight down, my x's again will cancel. 6 and 2 leave me with 8y. -4, -3 leave me with -7z. And 50 and 24 leave me with 74. Okay, so this is now my 5th equation. So what I'm looking at now is 2 new equations that I just created that now will help me solve, right? Because I have 2 equations and 2 unknowns, which is what we did in the last video. So I'm going to use elimination, but I'm going to go ahead and write down in English what I'm doing. Use equation number 4 and equation number 5 to solve. And again, I'm going to go ahead and just scroll down here a little bit. I'll scroll back up so we can see the whole thing in a minute. Whoops, I scrolled too far. I can't see equation number 4. All right. So equation number 4, I'm just going to write them here. Number 4 is 14y minus 9z is equal to 110. And equation number 5, the second one we came up with, is 8y minus 7z is equal to 74. Okay. Now I want to do the same idea here. I want to clear a variable. I can either clear y or I can clear z. The y numbers are a lot bigger, so I'm going to pick z just because the numbers are smaller. Now I can't multiply 9 by something to make it 7, and I don't want to multiply 7 by something to make it 9 because that's going to involve fractions and I don't want to do that. So what I'm going to do is think of the least common multiple. What is the smallest number that 9 and 7 both go into, which is 63. So I want to make one of those a positive 63 and the other one a negative 63. That way they'll cancel. So I'm going to have to multiply both equations by something to achieve my goal. So the top one, I'm going to go ahead and just leave that one negative. So I'm going to multiply by a positive 7. Because if I multiply by a positive 7, that will give me the negative 63. Which means on the second equation, I need to multiply by not only a 9, but a negative 9. So it will change that into a positive 63. Okay, so I'm going to go ahead and write out. If I distribute this 7 to the entire equation number 4, 14 times 7 is 98y. Negative 9 times 7 is negative 63z. Is equal to 110 times 7, which is 770. Then on the second equation, I go ahead and distribute that negative 9. So 8 times negative 9 is negative 72y. Negative 7 times negative 9 is positive 63z. And 74 times negative 9 is negative 666. Because math is the devil, right? Just kidding. No, we're going to get rid of that. Here we go. All right, so we're going to draw our line, and we're going to go ahead and combine straight down. So 98 minus 72 leaves me with 26y. My z terms are opposite, so they're going to cancel. And I'm left with 104 on the right-hand side. So now this is something obviously super easy to solve for y. I just divide off that 26. So I'm going to divide by 26. which tells me that y is equal to 4. Okay, so yay, I have one answer. I have my y answer, but I still need to figure out what x and z are. Okay, now it wouldn't do me any good to take this y equals 4 and plug it back into one of my original 3 equations, because even though I know what y is, I would still be left with 2 things that I don't know what they are. So instead of plugging this back into equation 1, 2, or 3, I'm actually going to plug it right back into either equation 4 or equation 5, because those 2 equations have y and z only. So now that I know what y is, if I plug what y is into the equation, I should be able to easily solve for z. So I'm going to scroll back up here, and I'm going to go ahead and just plug it into equation 4. So I'm going to say plug y equals 4 back in to equation 4 to find z. And you could use equation 5. I'm just picking equation 4 because, well, it's the first one I see. All right, so we're going to do 14y minus 9z equals 110. That's my equation number 4. And I'm going to plug the answer that we just got, which is y equals 4, into this equation. So I get 14 times 4 minus 9z equals 110. 14 times 4 is 56 minus 9z equals 110. Then I move my 56 to the other side by subtracting. So I get negative 9z is equal to positive 54. And then to get z by itself, all I have to do now is divide off that negative 9. So if I divide both sides by negative 9, I end up with z is equal to negative 6. Okay, so now I have 2 of my answers. I have y and I have z. So now that I have 2 of my answers, now I can plug it back into one of my original 3 equations, because since I know 2 of them, I can plug those 2 in and solve for the one that I don't know, right? So I'm going to go ahead and plug it into, I'm going to plug it back into equation number 3, because the one value that we have left that we're looking for is x. And notice of the 3 equations, x is all by itself in equation number 3. So I am going to plug y equals 4 and z equals negative 6 into equation 3 to find x. So equation number 3 is x minus 3y plus 2z is equal to negative 25. So I don't know x, but I know y is 4, and I know z is negative 6. So I should be able to simplify. So I end up with x plus 12, I'm sorry, not plus 12, minus 12. Wait for it. Minus 12 is equal to negative 25. My 2 negative 12s combine to give me negative 24. And then I move that 24 over by adding, which means that x is equal to negative 1. Now we have all 3 answers. We know what y is, we know what z is, we know what x is. One thing that's important to note is whenever we are solving a system of 3 equations, we're actually looking for a point of intersection, right? So whenever we were solving for a system of 2 equations, remember we had our y-axis and we have our x-axis, and we have 2 lines, right, out in space somewhere, and we're trying to figure out where's that point where they cross, and that was our solution. So we wrote it as an ordered pair x, y. Well, now that we have a system of 3 equations, we're actually, instead of looking in 2 dimensions, we're looking in 3 dimensions. So now we have our y-axis, we have our x-axis, and now we have our z-axis, which is coming out for our 3rd dimension. So we're looking for these different lines, right, in 3D, the point where all 3 lines cross. Okay, so the point where all 3 lines cross is going to be an ordered triple. So you can see up here in our instructions up at the top, it says ordered triple. So we're going to write this as x, comma, y, comma, z. Okay, anytime you're given letters, we pretty much always put them in alphabetical order. So if you're dealing with A, B, and C, L, M, and N, whenever you get your answers, write them in alphabetical order. Okay, so down here I'm just going to go ahead and write my solution in XYZ order. Once I find my pen, there it is. All right, so I have x is -1, y is 4, z is -6. So this is my solution for this system of 3 equations. Okay, so quick rehash really quick. I'm going to zoom out just a little bit so I can show the whole problem at once. Okay, so what we did is we basically took 2 different pairings, right? The first time we used equation 1 and equation 3 to get rid of x. That gave us an equation with only y's and z's. Then we took the pairing of equation 2 and 3 to also clear x. So we came up with another equation that had only y's and z's. Now that we have 2 equations, equation 4 and 5, that only have y's and z's, we can easily use those 2 equations to solve for either y or z. Once we get that answer, we plug it back into one of our equations that has 2 variables. And then once we have those 2 answers, then we can put those 2 answers back into one of our original to get that 3rd variable. Okay. Let's go ahead and look at another one. Same idea here. I'm going to go ahead and start with equation 1, equation 2, equation 3. And just to be a little bit different, I'm going to go ahead and clear z on this one. Okay. So if I want to clear z, notice on equation 1, that z term is really easy to work with, right? Because there's no number in front of it. So if there's no number in front of it, that's a good one to change by multiplication so that it ends up being the opposite of the other equations. So I'm going to go ahead and start with equation 1 and 2 to clear z. So I'm going to say use equation 1 and 2 to clear z. Okay, so if I clear z this first time, when I do this again, I need to clear z again. Okay, so for 1 and 2, if I want those z's to cancel, then my z from equation 1 needs to be a -2z. So that means I need to multiply equation 1 by -2. Okay, when I do that, I'm going to get -12x. I'm going to get -6y. I'm going to get -2z. And I'm going to get that equal to -58. Okay. And then equation 2 is going to stay exactly the same as it was. I have x minus 3y plus 2z is equal to 19. And now I can go ahead and draw my line and add my 2 lines together, or my 2 equations together. So my z's are going to cancel, and I'll be left with -11x minus 9y is equal to -39. So this is going to be my 4th equation. Okay. Now I need to come up with a 5th equation that also has only x's and y's. So I used 1 and 2 to clear z the first time. So I have 2 options. I could use 1 and 3, or I could use 2 and 3. So let's think about that. If I use 2 and 3, notice one of them has a 2z, the other one has a 3z. So I can't just multiply just equation 2 by something, or multiply just equation 3 by something. I'm going to have to multiply both of them by a number to make those z's opposite. So I really don't want to pick equation 2 and 3. I'm going to go ahead and pick equation 1 and 3 because I can easily see that by multiplying equation 1 by -3, then my z's will cancel out. So you get to choose the pairing, but always pick the pairing that requires you to do the least amount of work, obviously. So we're going to say use equation number 1 and equation number 3 to clear z. Okay. So we already talked about how we need to multiply equation number 1 by -3. So if I multiply equation number 1 by -3, I'm going to get -18x minus 9y minus 3z is equal to -87. And then whenever I'm going to be combining that to equation number 3, so I'm going to go ahead and write equation number 3 here, which is x minus 3y plus 2z is equal to 19. Okay. I go ahead and draw my line, and I combine straight down. So my, something should have canceled. What did I do wrong? Oh, I wrote equation number 2. You don't want to do that. We're writing equation number 3. I'm losing my mind. All right, so equation number 3 is 17x minus 2y plus 3z is equal to 114. Sorry about that. All right, so now that we have our new equation number 1 and our equation number 3, now we can combine down, which will cause our z's to cancel. So we're left with negative 1x minus 11y is equal to positive 27. And this is going to be our 5th equation, right? So we're going to go ahead and take equation 4 and equation 5 and solve for either x or y. So I'm going to write down here, use equation 4 and equation 5 to solve. So I'm just going to write them below here. So I have negative 11x minus 9y equals negative 39. And then I have negative 1x minus 11y is equal to 27. So now that I have these written, which one do you think would be the easiest to clear? Probably x's, right? Because our x's, I can easily just multiply one of them by something, right? And multiplying my second equation, right, my equation number 5 by negative 11 will help me to clear those. If I was going to clear y, I would have to multiply both equations by something to make those y's opposite. So I'm going to go ahead and just over here to the side multiply equation number 5 by 11. So I'm going to rewrite equation number 4, which is negative 11x minus 9y equals negative 39. And then I'm going to distribute that negative 11 through equation 5, which is going to give me positive 11x, positive 121y, and on the right-hand side, I'm going to get negative 336. Okay. So now I can go ahead and add those two equations together. My x's will cancel, and I'm left with 112y is equal to, oh no, I wrote the wrong number. I'm sorry. This number right here should have been, when we multiply by negative 11, I should have gotten negative 297. Sorry about that. So negative 39 and negative 297 is negative 336. And now I can easily solve for y by just dividing off my 112. So I end up with y is equal to negative 3. So now that I know what y is, I can plug it back in to figure out what x is, because I have two equations, right, 4 and 5, that have just x's and y's. So I'm going to go ahead and I'm going to plug mine back into 5. Again, it doesn't matter which one you pick. So I'm going to say plug y equals negative 3 into 5 to find x. I picked 5 just because it has smaller numbers. So I'm going to write what equation 5 is. It's negative 1x minus 11y equals 27. And then I'm going to go ahead and plug in what I know y to be, which is negative 3, which is going to give me negative 1x plus 33 equals 27. And then I'm going to subtract 33 from both sides, which will cancel, and I have negative 1x is equal to negative 6, and then I just divide off that negative 1. So I end up with x is equal to positive 6. And now that I know what y is, and I know what x is, now I can plug x and y back into one of my originals to find z. So if I look at my 3 original equations that I could potentially plug these back into, if I'm solving for z, the one that has the easiest looking z to isolate would be equation number 1. So that's the one I'm going to plug them back into. So I'm going to go ahead and write plug y equals negative 3 and x equals 6 into equation number 1 to find z. So equation number 1 is 6x plus 3y plus z is equal to 29. And then I'm going to plug in the values I know. So I have 6 times x, which we know is 6, plus 3 times y, which we know is -3, plus z equals 29. 6 times 6 is 36. 3 times -3 is -9, plus z equals 29. 36 minus 9 leaves me with 27, plus z equals 29. And then I move my 27 to the other side, which means that z is equal to 2. So once I know what x, y, and z are, I always write my answer as an ordered triple. So this will give me 6, -3, 2 as my solution. Okay. We're kind of okay with the process using our original 3 equations to eliminate one variable so that I'm left with 2 equations that only have 2 variables, which then I can solve. Okay. Let's look at one more that looks a little bit different, and then I will let y'all try some. Okay. All right. So this one is still a system of 3 equations because obviously we have 3 equations and we have 3 unknowns. What's different about this one is that not every single equation has all 3 variables, which is okay. So I'm still going to go ahead and number them 1, 2, and 3. This is number 1, this is number 2, this is number 3. And I'm going to go ahead and just pick a letter to clear. Now I can clear A's, I can clear B's, or I can clear C's. So if I look at this, if I want to clear A's, I would have to use equation number 1 and 2, right? And I could multiply equation number 1 by -2. Or I could clear B's, but to clear B's, I would have to use equation number 1, equation number 3, and those are not good numbers, right? Because I would have to multiply both equations by something to make those opposites. Or I could clear C, and if you notice, equation 2 and 3, our C terms are already close to being opposites. They're identical. So it'd be really easy to just make one of those negative. So I'm going to go ahead and choose that route of clearing C. So I'm going to write down here that I am going to use equation 2 and equation 3 to clear C. So I'm going to go ahead and clear C. Now, it doesn't matter which one I multiply by a -1, so I'm just going to do equation 2. So -1 times equation 2 is going to make that a -8a, a -2c, and a -30. And then we'll just leave equation number 3 the same, which is 6a plus 2c equals -22. So I'm going to draw my line, combine down, so my c's will cancel. But notice my first column, I can't combine 8a and 6b. Oops, that should be a b. 6b. Those are not like terms, right? They have different letters. So I'm just going to write them out side by side. -8a plus 6b equals -52. So this is my 4th equation. Now, looking back up at the 3 equations I started with, 2 and 3 are the only equations that I can use to clear C, because they're the only 2 equations that have C. So I can't go through the process again, but notice that this 4th equation that we just created has an A term and a B term, right? And if you look at our first 3 equations, we have one that has an A term and a B term, which is equation number 1. So I actually don't even have to go through the process again. This one saved me a little bit of time. I'm going to go ahead and just use equation number 1 and my new equation number 4 to solve. So equation number 1 is 4a plus 7b equals 6. That equation number 4 we just came up with is -8a plus 6b equals -52. So I can see to solve, the easier one to solve for would be A's, because one's a multiple of the other one, right? B's, I would have to make some pretty big numbers to get opposites. So I'm going to go ahead and multiply equation number 1 here by a positive 2. And that will give me positive 8a plus 14b equals 12. And then our fourth equation can stay the same. Negative 8a plus 6b equals negative 52. I draw my line and I combine down, which causes my a's to cancel, which gives me 20b is equal to negative 40. And then to get b by itself, I just divide 20 off of each side. So I end up with b is equal to negative 2. So now that I know what b is, I can plug it back in either to equation number 1 or equation number 4 to figure out a. So I'm going to come up here and just say plug b equals negative 2 into equation 1 to find a. So if I plug in, let me go ahead and write it, it's 4a plus 7b equals 6. So 4 times a plus 7 times negative 2 equals 6. I multiply that out, which gives me negative 14. Then I can move that 14 by adding. So I end up with 4a is equal to 20. And then I can divide off that 4, which tells me that a equals 5. Now from here, notice all these equations just have 2 values. So I could take a equals 5 and plug it into equation 2, or I could stick with b equals 2 and plug it back into another equation to find c. It doesn't matter which way you do it, as long as you plug it back in and find the one that's missing. I'm going to go ahead and just stick with the b equals 2. Whoops, where's my, there it is. So I'm going to go ahead and stick with b. Oh my gosh, I can't see this little thing. Where did it go? All right, so we're going to go ahead and plug b equals negative 2 into, all right, we need to find c. So we need one with a b and a c. So equation 3 to find c. So equation 3 says to do 6b plus 2c equals negative 22. So we do 6 times negative 2 plus 2c equals negative 22, which gives us negative 12 plus 2c equals negative 22. I can move my 12 by adding, so I'm going to add 12 to both sides, and I get 2c is equal to negative 10, and then I just divide off my c, which gives me c is equal to negative 5. So now that I know what b and a and c are, I just want to go ahead and write them as an ordered triple. So I'm going to write it in ABC. So 5, negative 2, negative 5. That's my solution. Okay. All right. So there are 2 for y'all to try. And I will tell you, if you want to be able to check your work with my work here in a minute, on both number 1 and number 2, I cleared X first. Now you can clear any variable that you want and still get the correct answer, but if you want to be able to check your work with mine, I cleared X as my first variable. Okay, so I'm going to give y'all a few minutes. Go ahead and pause the video, and then when you're ready to check your answers, go ahead and play it and we'll see how you did. Okay, so when we look over practice problem number 1, like I said before, I cleared X using equations 1 and 3, and then also using equations 2 and 3. Now, if you did a different pairing, your equations might turn out a little bit different, but you should still get the same solutions at the end. Okay, once you clear X twice, that should give you equation 4 and equation 5, which you should then be able to use and solve. Again, your equation 4 and 5 will look the same as mine if you use the same equations to clear X, or they may look different if you use different equations to clear X. Okay, so once you have your equation 4 and 5, then you just solve for either y or z, and then just start plugging them back in. Okay, if you need a little bit more time to look this one over, feel free to pause the video so you can check and see where you might have made a mistake, or if you're still working on it, you know, move forward from there. All right, but I'm going to go ahead and scroll down and look at practice problem number 2, which ended up being kind of an interesting one, right? Because if you try to clear x using equation 1 and 2, what happens is everything cancels out and you're able to actually solve for y right off the bat. So y equals -5 is sort of like the equation number 4 that we come up with, which is okay. We still need to go ahead and clear x again. So I use equation 2 and 3. You might use 1 and 3. It doesn't really matter. You'll get the same answer either way. So when you clear out your equation, whatever you end up with for equation number 5, now you should be able to take that answer that we got of y equals -5 and plug it into our equation number 5 to go ahead and solve for z. So this ended up being a little less work than the other ones we've done. And then once we know y and we know z, then we can plug it back into find x. So again, if you need a little extra time to look this over, feel free to pause the video. That is the end of section 2.4. So you should now be able to complete part 2 of that homework assignment. If you have any questions, feel free to give me a holler. I'll help you out. Okay, bye.